So regular expression is similar to finite automata, but in regular expression, basically what we are doing is representing the set of languages, right? So regular set ਨੂੰ ਆਪਾਂ ਜਦੋਂ represent ਕਰਦੇ ਹਾਂ, so there is a algebraic notation for representing that, and that is a regular expression. Here also we do not have acceptance or rejection. Just we are saying that we are representing these set of strings through the regular expression, and this is bit easy to represent and compact to represent. Otherwise, if आपने कोई DFA है या NFA है, that is a wider like diagram. But in regular expression, in a small, simple algebraic notation, we are represent the same thing over here. And regular expression and finite automata are equivalent to each other. Whatever we are drawing in the finite automata, we can represent the same thing to the regular expression as well. So, दो सिंबल्स है जिहड़े आपां यूज करते हैं इहदे च एक अपने कोल होंदा है asterisk. So asterisk is there. So what is asterisk? That is clean closure. So what this asterisk means? Asterisk means, suppose there is a input symbol A, I put asterisk on it, and another symbol is plus, I put A plus. So what is the difference between A asterisk and A plus? So repetition of the symbol A 0 or more times, and plus means repetition of this input symbol 1 or more times. So at least once, right? So that is at least, asterisk means it can or it can more than 0. So then in regular expressions, just write down 3-4 lines. Let sigma be an alphabet. Let sigma be an alphabet and denotes the empty set. Oh, sorry. Let sigma be an alphabet, full stop. The regular expressions over sigma, the regular expressions over sigma, and the sets that they denote, and the sets that they denote are defined recursively as follows. Are defined recursively as follows. So first point is phi is a regular expression. Phi is a regular expression and denotes the empty set. Second, epsilon is a regular expression and denotes the set epsilon. Third is, for each small a, for each small a in sigma, A is a regular expression and denotes the set A. For each small a in sigma, comma, A is a regular expression and denotes the set A. Fourth, if small r and small s are regular expressions denoting capital R, denoting the languages capital R and capital S respectively, then R plus S, RS and R asterisk are regular expressions that denote the sets R union S, RS and R asterisk respectively. So now, see in this full terminology, capital R and capital S, they are basically representing the languages of the finite automata. So if we go back and we we have written L brackets M, that was the language of the finite automata, and the notation we have used it in the form of the set, curly braces X with some property. So set of the strings that are accepted by that finite automata, that becomes the language of that automata. And now R is representing some set of strings that are accepted by some finite automata. S is some set of strings that are accepted by the finite automata. Now we say that R union S, so it will give us the set of strings that are acceptable by the finite automata of this and finite automata of this, right? So similarly, corresponding to capital R, there is a regular expression small r. So whatever the strings that are accepted by the finite automata, so they are represented. Now I am using the word represented. Here I am using the accepted. So the strings that are accepted by this finite automata, they are being represented by this regular expression. Similarly, this language is represented by this regular expression, and union is represented by the symbol plus. And in the case of the set theory, we are using the union as the symbol. But in the form of the regular expressions, we are using R plus S. Similarly, in the form of concatenation, so this is the language, this is the language, so concatenation, so this is the new language that has been formed, and this is the regular expression corresponding to that. And similarly, R asterisk is the regular expression set that is represented by the set of strings accepted by the particle, and this is the corresponding regular expression, right? So finite automata and regular expressions are interchangeable. If we have been given the regular expression, we can draw the corresponding finite automata. If we have been given a finite automata, we can write the regular expression corresponding. So now we'll do some practice on 3-4 regular expressions, how to write the regular expressions using these symbols only, right? So please let me know if we have written the regular expression 0, 0. So what is the set of strings that are represented by this regular expression?
Asterisk sign, 0, then
0,
asterisk sign, 0, 0, 0, next.
Ajay?
0 plus, also 0 plus.
So read the point 3 in your notebooks. Now let me know what is the answer. Only one string is there, right? Because we haven't used any symbol from here. Have we used any symbol? Only concatenation operation has been performed. If you talk about the regular expression, if we use the concatenation operation over here, so capital R represents 0, capital S represents 0, RS represents 0, 0. So correspondingly R is 0, S is 0 and RS is 0, 0. And what is the string over here is? Clear? So only one string is there that is represented by this particular regular expression. Right? So then, write the regular expression, just note down, write the regular expression that denotes all strings of zeros and ones. Write the regular expression that denotes all strings of zeros and ones. So first we understand what we need to represent. So reading this problem, let me know what are the strings that will be represented by the regular expression that will be written.
0.
Just yes, go.
0.
0,
1.
1,
0, 0, 1, 1.
yes.
0, 0, 1. 0, 1, 0, 1.
Any more? Just read out the example again, what we have to. 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0. Any string that is made up of zeros and ones. Every string that is made up of zeros and ones, we need to represent through a regular expression. Right. So now, first thing is clear that any string, whatever we are talking about, that can start with 0, that can start with 1 as well. So it means 0 or 1. And how many times 0 and 1 can be repeated? Any number of times? And any means 1 or more or 0 or more?
0.
0 or more. So what is the symbol that is used for or? Or. Union. So what symbol will come
Plus.
for what input symbol? 0
Plus 1. 0 plus 1. Then asterisk.
0 or 1 in any order, any number of times. And this is very important question in final exam. Sometimes this simply asks, write the regular expression to accept any string of zeros and ones. So that is the simple answer. So then move to write the regular expression of strings of zeros and ones. Write the regular expression that represent strings of zeros and ones with at least 2 consecutive zeros. With at least 2 consecutive zeros.
And 1 or
Ajay, बोलो.
0, 0.
0, 0.
Plus 1. Then asterisk.
So 0, 0, 1 है.
Understand?
Plus 1.
Sir, add है कि और 0 और 1 0 और 1 बोल रहे हैं क्या?
Write the yeah, represents all strings of zeros and ones with at least two consecutive zeros. ਹੁਣ ਪਹਿਲੇ ਵਾਲਾ ਜਿਹੜਾ ਰੈਗੂਲਰ ਐਕਸਪ੍ਰੈਸ਼ਨ ਹੈ ਉਹਦੇ ਤੋਂ ਮੈਨੂੰ ਆ ਚੀਜ਼ ਦੱਸੋਗਾ ਕਿ ਆਲੀ ਸਟ੍ਰਿੰਗ ਬਣ ਸਕਦੀ ਹੈ ਇਹਦੇ ਨਾਲ ਕਿਉਂਕਿ ਆ ਜਿਹੜੀ ਪਹਿਲੀ ਵਾਲੀ ਰੈਗੂਲਰ ਐਕਸਪ੍ਰੈਸ਼ਨ ਹੈ ਇਟ ਇਜ਼ ਸੇਇੰਗ that either 0 0 can be repeated in pair or 1 can be repeated, but this cannot be derived and this should be
0 plus.
if we talk about this, so it will be repeated like this, so only this pattern is represented.
0 where 0
Where?
plus 0
0
plus 0 0 plus 1 equal to
क्या करके होगा simple, very simple answer. Any number of zeros and ones before the two consecutive zeros and after the two consecutive. At any position in the string, we need only two zeros. We got two zeros, and before that anything can be there. After that anything can be there. Right? Next, try karo. Write the regular expression that denotes all strings of zeros and ones beginning with 1. Write the regular expression that denotes all the strings of zeros and ones beginning with 1 and not having two consecutive zeros. Not having two consecutive zeros. So first you try to write some of the strings that are denoted by this regular expression. Then you try to write the regular expression, inferencing the pattern out of it. Now what we have to think is, what combination of two characters to be repeated so that two zeros are never together. Think of right, you are on the right track. One can be there, they can be combined, but 0 0 cannot be combined. So how to avoid two zeros? So which patterns to be repeated so that two consecutive zeros are not there by repetition?
One asterisk, then zero asterisk.
Zero
Sorry, zero asterisk, one asterisk, then zero, then like
Any good practice?
So 1 plus I
One,
1 0 1
0 1
1 0 1. Three characters to be repeated.
1 plus 0 1
1 plus
1 asterisk,
1 plus 0 1. You can try for 0 1. So this is the answer. Then write down the regular expression. Write down the regular expression that denotes all strings of zeros and ones whatsoever. Write the regular expression that denotes all strings of zeros and ones whatsoever that do not have two consecutive zeros. In the last example, what we have missed one thing, there were two parts. First was there shouldn't be two consecutive zeros, and what was the another condition?
Begin with one.
That's why one is there at the beginning, right? Otherwise we must have written 0 1. Okay, so try this one.
0 1 plus 1 0 1 0 1 0 1 plus 1.
What else? Small extension of the previous one.
0 1 plus 1 0 plus
0
1 0 1 0
plus 1.